Heinemann Higher, Chapter 6, Differentiation, the mixed exercise, success at the end. Number 13, a former higher question. So here it is, there's the diagram. A winding river has been modelled by this curve, very convenient, and a road is a tangent to the river at this point A, 1, -8. Find the equation of this tangent and hence find the coordinates of B where it must intersect it again. So why didn't it just say find the coordinates of bridge B, if they're going to be very concrete about it all. Right, so basically get the equation of the tangent, then substitute that equation into the equation of the curve to find the point of intersection. Well, here's the coordinate equation. They've already worked out the y coordinate, so I don't need it immediately. However, I'll need it to differentiate to get the gradient equation. So that'll be 3x squared minus 2x minus 6. Then, I'm not finding stationary points. Don't assume that this point B, just because it looks close to the top, is a stationary point. I merely need this to find the gradient at A. So, I know this about A. At A, x equals 1, which means at A, the gradient will be given by the derivative, which will be 3 times 1 squared minus 2 times the 1 minus 6. So that's going to be 3, take away 2, take away 6, so that's going to be -5. So the gradient is -5. So now I've got, for this red line, I've got a point on it and I've got its gradient. Unfortunately, it's not the point on the axis, the y-axis. That would have been handy. I could have gone y equals mx plus c straight off. So instead of that, to find the equation of the line AB, being the tangent, I'm going to have to use y minus b is mx minus a. So y minus the y coordinate, so plus 8, is -5 times x minus the x coordinate, minus 1. Very nice and integral, that's just going to be y equals -5x plus 5 minus 8 minus 3. Very handy form. So here's my original equation, here's my tangent, and then to find the coordinates of the point B, I just need to substitute this equation into that one. So to get the coordinates of B, I'm going to substitute not so much 2 into 1, but in fact 1 into 2, because I want this to come first. So I'm going to say this. Substitute the equations. Substitute 1 in 2. So in writing out 2, I carry out the substitution applied by 1, which is put x cubed minus x squared minus 6x minus 2 instead of y equal to -5x minus 3. Everything over to one side so I can factorise it. X cubed minus x squared minus just 1x, but plus 1 equals 0. And now, there's a polynomial degree 3 to factorise. In this chapter, still chapter 6 in unit 1, whereas factorising polynomials is in unit 2. But even if it were, as it was in the exam in unit 2, we'd already covered unit 2, you still wouldn't need to go through that synthetic division because of the nature of the question. I know that this cubic function must have 3 factors, and I know that from this system of equations here, that I can see the intersections, that at A I've got a double root. So 2 of the answers are there, and there's a single root to this equation at B. So out of the 3 factors, I already know 2 of them. The double root at A means I've got these double factors. If x equals 1 is a root, then x minus 1 must have been the factors. And then I simply need to find this remaining factor to reconstruct this equation, much the same way as you do with quadratics. So the first times the first times the first gives x cubed, so it must be x. The last times the last times the last must give me 1, so that's a positive 1, it'll have to be another positive 1, and there you go. So x equals 1 twice, or x equals -1 once. X equals 1 twice, tangent, x equals -1 once, clean cut. Which means that at B, x equals -1. So all you have to do then is find the coordinates of y, the y coordinates rather. Well, substitute that into this one here, into this one, much simpler, both work of course, which means that y is going to equal -5 times -1, whoops, take away 3, 5 take away 3, 2. So y is going to equal 2. So there's my answer so far. At B, x is -1, and just make it a bit neater, y is 2. And then just write that again. So B is the point, -1, 2. Where will I put that? Over here. B is the point, -1, 2. There it is, question 13.